Welcome to Lesson 1, Where is the Earth Changing? This is for Activity 1.2, Worldwide Patterns of Earthquakes. So if you could open up your book to 1.2, we're going to take care of that today. So just like Activity 1.1, we're just going to shift from taking a look at volcanoes to trying to figure out where earthquakes happen. So the expectation is you finish Activity 1.2 today. So if you could just take a few minutes, either think about it yourself if you're working by yourself, or talk with your team. What do you know about earthquakes? What have you heard about earthquakes? So go ahead, pause the video and talk about this with your team. Now, the next thing I'd like you to do with your team is, where do you think earthquakes usually occur? So again, pause the video for a minute and just go around, or if you're working by yourself, just think about it. But if you're working with a team, just go around and talk to each other. Where do you think earthquakes usually occur? So just like with the volcano video, we're going to take a quick look at some of the history behind earthquakes. Now we know the largest recorded earthquake happened in Chile on May 22nd, 1960, and it was a magnitude 9.5. And as you can see from this picture, there's quite a bit of devastation. Now, the most deadly earthquake that scientists have ever come up with happened in 1556, and they estimated that there was about 830,000 people that died. And in this region of China, a lot of the people lived in caves from soft rock. So if you can imagine an earthquake happen, a lot of these caves are going to collapse. China also had in 1976 an earthquake that killed 250,000 people. So you can see that these were very deadly. When you look at the United States, the largest earthquake ever recorded was a magnitude 9.2, and it happened in Alaska on Good Friday, March 20th, 1964. Now you can see these buildings aren't completely devastated like the picture that you saw here, but if you take a look, here's the street level on one side of the street, and then look where the street level is. So if these people are what, 5'5", 5'6", you're looking at a huge drop here, maybe 7 to 10 feet drop for this side of the street. So that was a huge devastation to this part of the country. Now, I don't know if you knew this, but we actually have part of the United States, mainland United States, that is actually on another plate. And if we go to California, if you've ever driven to some place like Los Angeles, you've actually driven over this. And I've flown over this, but I've never driven over it. And we know that this is the San Andreas Fault. And it moves on average 56 millimeters or about 2 inches per year. And it actually moves at about the same rate that your fingernails grow. So one part of this plate is moving in one direction, and one part of this is moving in the other direction. Now, if the current rate of motion continues, Los Angeles and San Francisco will be right next to each other in approximately 15 million years. So they're going to be neighbors. Now, how many earthquakes do we have in the world a year? Why are we talking about earthquakes? Well, actually, there's about 500,000 detectable earthquakes in the world each year. Now, it's a good thing that most of them we don't feel. Only about 100,000 of those can actually be felt, and 100 of them actually cause damage. So very few earthquakes that happen, we don't even feel, but very few of them cause damage. If we look at one of the most seismic active locations in the United States, it's probably going to be Southern California. They have approximately 10,000 a year. And out of those 10,000, only several hundred are greater than magnitude 3, and only about 15 to 20 are greater than magnitude 4. So, if there is a large earthquake, however, the aftershock sequence will likely produce many other earthquakes possibly for months to come. But thankfully, most earthquakes that happen in Southern California are fairly small. Now, how about here in the Midwest? So if we're looking at this map, Wisconsin would be right behind here. But we know that the New Madrid Fault, which is right down here, and right along this line is the Mississippi River. So the New Madrid Fault actually erupted, or there was a large earthquake that the epicenter was there back in 1811, 1812. And this, you might say, well, wow, it happened 2 whole years. Well, the earthquake happened, but then there was aftershocks. And some aftershocks can actually be stronger than the original earthquakes. And I've always heard stories about this earthquake where liquefaction put up so much debris into the air, it turned night or day into night. I heard that the Mississippi River actually ran backwards for a while. So it actually flowed backwards. And I also heard, and this is the most interesting one, because you can see how far away it is to Milwaukee would probably be about right here. So you're looking at almost the entire state of Illinois. It was such a large earthquake that church bells rang in the Milwaukee area. So if you can imagine some churches having church bells up in the steeple, that the earth shook enough so that you could hear those bells ringing. Now, what I'm going to have you do today is I'm going to have you do activity 1.2. So I'm going to show you a world map, and you do not have this map in your book. So I'm going to show you one, which is good because it'll be a color version too, where in the book you don't have any color. And what I'm going to have you do is you're going to take a look at it as you did with the volcano data. And you're going to look for patterns and relationships to where you think earthquakes are found, and not only where they're found, but where they're not found. Then you're going to talk with your group about the patterns you observe. Now, if you're doing this by yourself, obviously, you're just going to have that conversation with yourself internally, of course, and see if you can find any patterns. And then you're going to do questions 1 through 3 on page 4. And again, the page numbers may vary from year to year. So here is a look at the map. So when we look at making sense question, how does your prediction compare with what you found when you located the earthquake map data? So I asked you to think about it and to discuss it with your group. How does your prediction compare with what you found when you looked at this map? So earlier I asked you to pause the video, predict, where do you think earthquakes are going to occur? And either you're thinking about it yourself or you're talking with your team. Were you right? Were you not right? So just a quick sentence. How does your prediction compare with what you see on this map? So go ahead and do question 2. What patterns do you notice in areas where earthquakes have occurred around the world? So you can answer this yourself, or you can talk with your partners if you have partners. So you might not have partners. You might be doing this on your own. So where do you see patterns happening? And just write me a sentence or two. What patterns do you see? Where are they happening? Or maybe a pattern of where they're not happening sometimes works just as good. And then number 3, why do you think earthquakes appear in the places they do? So go ahead and pause this video and answer questions 1, 2, and 3 if you have not already. So go ahead, pause the video. All right, so you've had a chance to complete that. So let's take a look at what you came up with. So first of all, your predictions answers are going to vary. Some of you might have predicted correctly, some of you might not have predicted correctly. So the patterns that you might have seen is that earthquakes occur in lines or in clumps, similar to what you saw with volcanoes. Many earthquakes occur along the edges of continents, while others are in the middle of the oceans, or they might be in the middle of continents as well, because you see that here. Now, you might have also talked about how some of them occur in the very same locations that you saw volcanoes, because a lot of volcanoes actually produce earthquakes as they're erupting. So we're going to do that next. We're going to compare the maps, but you might have mentioned that. So did you see that they occur along these lines? And these lines are probably a little bit more evident with the earthquakes than they were with the volcanoes. You might have also said they seem to occur along the edges of the continents. Or if they are in the ocean, they tend to be along lines. There tends to be a pattern. And if you said all those things, that's awesome. Now, question 3, why do you think earthquakes appear in the places they do? Again, we're going to get to that later in the book, so keep that in mind. Why do you think they occur where they do? But we're going to move on for now because we are going to come back to number 3 later in the book. So the next thing I like you to do with procedures is after you examine the volcano and earthquake data separately, compare the 2 maps. Then you're going to talk with your groups about the patterns that you see, about where volcanoes and earthquakes occur, and then you're going to be completing questions 4 through 7. So first, let me put the map up here. So you got the volcano, very same volcano map you did in activity 1.1, and here's the earthquake map that we just looked at. So question 4, how do patterns in earthquakes and volcano data compare? So go ahead, pause the video. How are they similar or how are they different? Just a sentence or two. What did you come up with? So talk this over with your team or take care of this by yourself, but pause the video and answer question 4. All right, so you've had a chance to answer question 4. How about 5? What ideas do you have about why there are patterns in earthquakes and volcano data? So why do you think they occur where they do? What are your ideas? So go ahead and pause the video in just a sentence or two. All right, so let's look at 6. What ideas do you have about why some earthquakes and volcano data do not fit the patterns you observed? So you might have talked about there being various patterns. Okay, so do all of them fit along with that pattern? If not, why not? Just a sentence. Now, number 7. So sorry, earlier I said we were going through page 5, but I guess question 7 is on page 6. So 7, if you look at question 7, the driving question in this unit is, how is the Earth changing? How do you think volcanoes and earthquakes relate to the Earth changing? So do you think volcanoes and earthquakes cause change? Do you think they're an agent of change? Or do you think they're just benign, where they don't cause that change? So go ahead, pause the video, and just write me a couple sentences about this. And then finally, B, what questions do you have about how the Earth is changing? Do you have any questions? And again, when we think about science, you should always be developing questions. What about this? What about this? Why does this happen? Why are they located here? And that's one of the neat things about science. You should always do, once you get one question answered, you probably have 10 other questions that you now are wondering about. And that's that curiosity that we really want to get. So the next thing we like to do is I like to just go through some of the answers that you came up with. For 4, how do patterns in earthquakes and volcano data compare? Well, you might have said that the earthquake and volcanoes overlap in some places, such as along the edges of the continents, mainly in North and South America. It was really evident. Some islands have both volcanoes and earthquakes there. So these are a couple of good things you could have mentioned for number 4. Number 5, what ideas do you have about why there's patterns? Again, I don't have an answer here because answers are going to vary. There could be 20 different answers between all my different classes. But we are going to come back to this, and we are going to focus in on why do earthquakes occur where they do, and why do earthquakes occur where they do. So why do they both occur where they do? And then when we get to 6, what ideas do you have about why some earthquakes and volcanoes do not fit the patterns? Again, the answers are going to vary, but they should be based on your observations. And again, we're going to come back to this. Just like 7, we're going to come back to this. We're going to start to take a look at how earthquakes, how volcanoes do change the Earth. Now, one of the obvious things you could imagine is that volcanoes add lava to the surface of the Earth, changing its appearance, and earthquakes cause destruction of buildings on Earth. They can cause the land to change appearances. So there's lots of things that they could do as a result of this. Now, you can pause the video right here, but I do want you to maybe listen to this next part, because here's why. What about Wisconsin? Do we have earthquakes in Wisconsin? Could we have an earthquake in Wisconsin? Could you wake up tomorrow and feel an earthquake? Well, we're going to answer that question next. So when we look at seismic activity maps, and high hazard, very low. Here in southern Wisconsin, it's pretty low. So the chances of you waking up tomorrow morning and falling out of bed because of an earthquake are pretty slow, or pretty lim. They're pretty low. But could it happen? Well, here's a clipping. Quake hits Milwaukee. So this was published by the Milwaukee Sentinel a long, long time ago. You can see it's an older paper. So earthquakes have hit Wisconsin. One of the neat things that I was able to do probably about a decade or so ago, is I was able to go to the Geological Society. They have a place where they store rock samples. And one of the rock samples I saw actually had a fracture in it, which was caused by an earthquake. So I actually seen proof that there's been earthquakes in Wisconsin in the past. Now, when we look at this map, in 1947, Wisconsin earthquake took place on May 6, immediately south of Milwaukee. It was the largest tremor to be historically documented in Wisconsin, but it was not recorded by seismographs. And as a result of that, if you talk to some geologists, if you look at some websites, they're going to say no earthquakes have ever happened in Wisconsin. But we have proof that they've happened. I've seen that happen. And besides, when we talk about seismographs have only been accurately recording, earthquake data maybe in the last half a century. So there's a possibility that many, many earthquakes have happened in the past. They just weren't recorded, such as this one right here. But if we look at this map, here's Sauk County. Whoa, this one happened in Dane County, not too far from us. So here's all kinds of supposed earthquakes that have happened, Wisconsin earthquakes, that I could find. So what's the answer to could you wake up tomorrow and feel an earthquake? You could. You never know. What are the chances of the Nemadrid Fault having a major earthquake tomorrow? And remember, this is the one that we could feel in Wisconsin, that church bells rang in Milwaukee. It could happen. It absolutely could happen. That's the thing about earthquakes. Earthquakes cannot be predicted. Now, sometimes there's signs that it could be happening, but earthquakes cannot be predicted. So it might happen tomorrow. It might happen in the next, well, let's count it off. It might happen in the next 5 seconds. Let's wait for it. Now, I guess it didn't happen this time, but we just never know with earthquakes. So I'm going to have some of these videos. I'm either going to post them in Google Classroom, or if you check the website, they're going to be there. I'll post them somewhere. So if you want to take a look at these are some neat ones. And especially this one right here is just, jaw-dropping what happened here. And this is another neat one that I like to watch. And if we do cover it in class, obviously you won't be watching this video, but these are some of the neater, more recent videos that I've been showing my classes. So if you have any questions, if you have any concerns, if you need help completing this activity, please, please, please talk to your science teacher. Thanks. Have a good day.